So this is the final day. So in this day, 3 sessions are there. The first session started by 2 to 3:30 will be handled by Dr. Bhuvaneswaran. He is the professor and director of Ramanujam Computing Center, Anna University. So next session will be handled by one more resource person, and third session is also there. So as per our group discussion, 6:30 to 7:30, one test is there. From 7:30 to 8, valedictory is there. This is the today's schedule. So now let us start the session by Dr. Bhuvaneswaran. Let me call upon our assistant professor, Ms. Vaishnavi, to introduce our today's resource person, Dr. Bhuvaneswaran. Vaishnavi, ma'am.
Ma'am, actually, I'm Nivetika. I'm gonna introduce myself.
Okay. Now, Nivetika will introduce the resource person. Yes.
Very good afternoon to one and all present here. I, Mrs. K. Nivetika, Assistant Professor of CSC from Winter. I take immense pleasure in welcoming today's speaker. Today, we have the esteemed honor of welcoming Dr. R.S. Bhuvaneswaran, a postdoctoral fellow of JSPS, Japan. He had completed his postdoctoral fellowship in grid computing at Nagoya Institute of Technology, Japan, JSPS, in the year 2004 to 2006. Also completed his MTech in Computer Science Engineering, Pondicherry University in the year 1995 to 90. Done his BSc Mathematics in Madras University in the year 1984-1987. Have completed his PhD in Distributed Computing, Wireless Sensor Network, Anna University in the year 1999 to 2003. He is with Anna University for more than 26 years, and presently he is a professor with an additional responsibility of director, Ramanujam Computing Center, Anna University, Chennai. He published his research finding in more than 90 international journals and nearly 70 at international conferences. He guided 16 PhD scholars. His research interests include distributed computing, information security, and fault tolerance systems. It's my pleasure to welcome Dr. R.S. Bhuvaneswaran, sir. Sir, we welcome you, sir. The session is yours now.
Thank you.
Thank you, sir.
Thank you, one and all. Thank you, Madam Mad, for inviting me to deliver the lecture in this ATAL FDP. So it's my pleasure and privilege to be part of this FDP. Actually, initially, I thought of accepting and put up in the presentation on the intrusion detection system because some of my researchers completed the degree in the intrusion detection system using deep learning. I thought since present my research is on DGA, it's called domain generation algorithms. So it may be shoot well to our this LFDP because it's enhancing the cyber threat detection, right? So this is one of the major cyber threat. It's presently prevailing. So let me start my session introducing what's meant by this domain generation algorithm driven botnets. So interchangeably, I may use the word is DGA botnet or malware as simply the DGA. All refers to the DGA malware or DGA botnet. So usually domain generation algorithm is one of the most significant advancement in the malware over the past decade. So understanding the attack is crucial for protecting the network from malware threats. So DG is employed by the cyber attackers to generate the new domain names and IP addresses for malware's command and control servers. Let me give in detail in the coming slides. So overall overview is what's meant by the DG attack and how the DG is working, and for what do the hackers may make use of the DGA to attack the net resources, and then what are the major malware attacks with the DGA, and what are the targets, prominent targets, and what are the challenges in DGA attacks, and what are the techniques. Though the major techniques being employed in the major software players as well as the cybersecurity providers are the firewall majors. Right, I'm presenting is this one is let me present the what are the best botnet detection techniques available in the major software firewalls as well as hardware firewalls. And then from the academic research point, what is prevailing now. So before entering into the DGA, let me introduce the botnet. What is a botnet? So in the past 4 days, you maybe come across the many cyber threats or cyber attacks. Have a good sessions on all these cases. We touch upon this botnet to get insight into the DGA. Put in simple, botnets are the networks of the compromised computers, also known as the bots or the zombies, that will be coming under the controller of the malicious actor. Or the malicious actor will take the control of full the botnet and thereby creating the infected computers with the malware, allowing the attacker to remotely control them. So usually it will take the processor. Initially, it will be infected with the malware, the botnet, and then once it gets connection with the C2, shortly called as command and control servers, and thereby it is multiplied or generated the or affecting the other machines in the network. So what are the malicious uses of the botnets? So botnets are used for various malicious acts, including DDoS attacks, and it will be overwhelming target system with a flood of traffic, rendering it inaccessible. Though many solutions are being provided in past 2 decades, right? Still, it is a challenging one. And then sending out massive volumes of unsolicited emails as a spam, and then email the credential theft, harvesting usernames and passwords, sensitive information from infected devices. And then it will be multiplied or otherwise malware distribution. So distributing the additional malware on the ransomware to compromise the devices. So my today's topic is to introduce the DGA. What is DGA? How it works? Right. So let us get to know what's meant by the DGA. So DGA is it's a domain generation algorithm. The botnet is make use of this DGA and try to control or try to affect the systems in the network. So domain generation algorithm is a simple cyber threat strategy, or you can call it another angle. It's a technique used by the cyber criminals to evade detection and maintain control over the compromised. Usually the bots are running the same DGA to may generate the many domains to resolving to get into the CNC server. Because CNC server never generates any domain, it will may retain the certain DNS replies, we call this the NXD, or non-existence of domain servers. Based upon the DNS replies, it may get registered in the DGA. So thereupon it may take the full control. So let us slightly go in deeper what's meant by the DGA is. As I said, it's a cyber threat strategy. It's a type of botnet employ the domain generation algorithm to generate the large number of domain names dynamically. So DGA are one of the top known methods that make it harder for the malware victims to protect against attacks, and they have been used for over more than 10 years. Though the popular DGA is there in 2008, still it is a challenging one. So these domain names are used by the botnet's command and control infrastructure to communicate with and take the full control of the infected devices. This is to evade the traditional security measures. So usually all the firewalls or the most of the security software, it will take in control of the infected and they will try to isolate. But the domain names, actually the domain is not at all existing because these domain names may not be identifiable by the security software. Are the domain names blacklisted by the firewall also cannot be traced out. So how it is being functioning in the broad senses, the attackers can control a group of malware infected machines called the botnets remotely through the CNC server, as I mentioned earlier. So DGAs are used to generate the pseudo-random domain names, and the CNC registers a subset of those domain names and uses them to communicate with the malware. So the generated sequence of domain names are the pseudo-random due to the initial seed used by the DGA to generate them. So both the malware on the infected machine and the CNC is the same DGA and seed to generate the sequence of DGA domain names. If the malware tries to communicate with the domain name registered by the CNC and thus the resultant malicious activity starts. So the CNC cycle through the DGA domain name frequently, and the malware and infected machines will eventually connect to the. So there the test drive will start. So I put it in whatever I narrated in the diagram. In these cases, usually it starts with the client with the malware. It will generate the DNS query with the unknown domain generated by the DGA. And then the DNS replay, it's a DNX domain. So NX domain is a non-existence DNS error message that is received by the client. So this happens when the domain has been requested but cannot resolve the valid IP address. So not only the DNS names, it may resolve with the corresponding IP address as well. And thereby it taking control over the CNC server, or probably called as C2 servers. So DGA's botnets, other way of viewing is how the botnets are the DGA botnets taking full control of the malware. Though despite our protection mechanism, the sense is here the protection mechanism is, it may be the firewall. So the DNS queries NXT, right? It will be trying to register with these registrations out, and thereby it is evading and could not control the whatever may be the high cost firewalls. So how the DG attack is the purpose of, what is the purpose of using these DGs? Right. The purpose of using the DGV is to evade the traditional security measures that they rely on the static blacklists. So this is done by constantly changing the domain names. So like a Sybil will be changing the phase tag, right, only for the packet, but the entire domain in itself is changing its name. And these techniques make it highly challenging for the security systems to predict and to block the communication channels used by the market. So how these mechanics are, how the DGAs are being attacked. Usually DGA attacks leverage dynamically generated domain names, establish the resilient and evasive communication channels between infected systems and the command and control servers. Usually the mechanics are how the DGAs attacks is, though I mean many DGAs are working in different fashion, though the major is generating the domain names. After the way, in particular, the process of DG attacks may be, or otherwise the mechanics of DG attacks can be in the stages. It's a typical DG attacks. Right? Usually, in general, any DG malware, it will be starts infect by generating. Then it will start generate the names of the algorithms, and then it will be get registered the domains, and then it will be the command and control taking care. Right? Even if the primary C2 domains fall, it will botnet resolve the DGA domains, and then evasion and stealth it will be taken care of. Explain one by one what's mean by how it getting infected. How it is being initialized. Usually the process typically begins with the system becomes infected with malware that includes DGA module. So this malware could not be traceable, right? So upon infection, the malware initializes the DGA module. So it contains an algorithm designed to generate a set of pseudo-random domain names. The coming slide, I will show you how the random domains are generated, the algorithm which follows. And algorithm generation is nothing but the generation of the domains or domain generation algorithm. So this is a typical mathematical algorithm which uses many parameters to produce a unique sequence of the domain names based on the specific parameters such as the current date to make it the unique one, and system information or other dynamic factors. So each DGA signature or each may be called as a stringent. Okay, it is to generate the domains in the different manners. So the algorithm ensures that even with the same input parameter, the generated domain names changes over time, often or daily or hourly. The frequency may be anything, or maybe time or daily or hourly basis. Usually hundreds of thousands of domain names will be emerged from each run of this module. So usually any typical domain generation algorithm will be, there's a left hand side it's a code, right hand side is an algorithm. This is a typical domain generation algorithm, how it generates. So usually starts with a certain URLs, and then it creates a calendar instance, as in that current date is 12 or 14, it will be taking out, or sometimes certain DGH will be taking care of current week, maybe the 20th week or 30th second week something. So it is making use of the calendar to be either the current date or the current week or current timing, combined as a unique factor. And then it will generate the TLD or top level domains as strings. So the variable TL domains will be attached and the code enters here. So inside the loop, it will keep generate with attaching the base 64 encoding. So there it generates a certain unique random number. And this is a typical one. So I generate the 19 characters and then finally it generates the random numbers. The domain names generated by this algorithm will be looking like this. So the many domain names, it may be the redundant substrings, or it may be redundant to words, or based upon the entropy. As an attendant, right? You know what's mean by entropy. You might have come across this entropy in different contexts in the cryptography. The machine learning, this entropy is being used for the decision tree algorithms, right? To get the information. Here it is the entropy is being used for the randomness. So the term DG, as I said, no, DG are using a variety of the mathematical randomized algorithms to generate the various unique patterns along with the, as I said earlier, time using the calendar features as time, date, and the week. So the domain name with its genuine and the malign domain names. You may come across, there may be any genuine name here in the generated, but these domain names are generated, it's automatic. The challenge is how to differentiate between this domain name and the genuine domain name. In the later part of the slide, let us see what are the measures being taken or how they are being classified. So coming to the third stage, as I said, now first thing is initialization. The malware is being injected, and then malware generates the algorithms. And once this malware is being generated, it will be domain how it is being registered, though it is not the genuine malware. The malware uses the generated domain name, as I mentioned in the earlier algorithms, to establish the communication with the command and control servers controlled by the attackers. Because everything starts with how this being is, the C2 is being under the control of the attacker. So to make the tracking and blocking more challenging, the attackers registers only the subset of generated domain. Though they are able to generate all these domain, they will generate. We use the subset of it because then because modern firewall may trace a set of domain names being generated. You can check it out in the firewall. Keep on getting the similar type or slightly varying domains coming across, the intelligent firewall may shut it off. So to avoid that one, they instead of generating all domain names, they're making use of the subset of the generated domain names. So leaving security systems uncertain about which domain will be used for the malicious activities. Though some of them might have been blacklisted earlier. So the fourth one is, as I said, the injection, registration, injection, generation, and the registration. I'm registering the CNC. After registering, how the command and control it's being activated. So the dynamically generated domain names, the domain servers as a rendezvous points between the infected systems and the command control servers. The malware periodically queries these domains for instructions or updates from the attackers, enabling them to maintain control over the compromised systems. So attackers only need to register a single one of those domains generated by the DJ to have a fresh CNC entry. I think get me. So initially DJ generates thousands of DJ names. From there it is the algorithm making use of the knowledge only subset. But while registering to get in the control, it get the only one domain. Even they're able to admission into the one infected or malign domain name, it is sufficient to affect the entire systems. So afterwards, the evasion and the stealth. Right? So evasion and stealth is nothing but how the data are being expired. So we'll otherwise call this a data exfiltration. So data exfiltration, nothing but how the data are being used for some other purposes. So by regularly changing the domain names, and the DG attacks evade traditional security measures that rely on the static domain blacklists. So this make it very difficult for security systems to predict and block the malicious communications based on the known domain name. So malware can use these domains to transmit sensitive information from the compromised system to external servers controlled by the attackers. So DGs are the adaptive in nature. So since right nowadays we can see many type of attacks from the malware are more intelligent, more. That's what our detection mechanism to be cope up with that. So this DG is also maybe more adaptive in the meaning this attackers can adjust the algorithm or its parameters in response to the changes in the security landscape or the security measures. So in addition to the command and control server, DG generated domains may also be used for the data exploitation, as I said, data being used for the other purposes. So malware can use these domains to transmit sensitive information from the compromised system to the external servers or the controlled by the attackers. So these attacks are adaptive. The meaning in the sense is attackers can adjust the algorithm its parameters. Right. So the algorithm what we are focusing here in our actually I'm working. I mean my research colleagues are working on this DGA detection algorithm. So we are focusing on this type of adaptive natures. So usually a domain name, right? This adaptability only allows them to stay one step ahead of the security measures that attempt to detect and block the DGA generated domain. So that's what while detection algorithm also must be adaptive in nature. I'll come to the point later how while talking about the detection technique algorithms. Now let us see. I mean, why the two hackers to use DGCS. So cybersecurity products and the services try to identify the IP addresses of the computers and websites that are communicating with the C2 servers and infect devices to stop these malicious activities. So based on these threat intelligence security provider, they can block any traffic that is going to or coming from these IP addresses. So cyber criminals need to constantly change the domains to evade detection by intrusion prevention systems, security gateways, blacklists, signature filters, reputation systems, and other security technologies. So threat actors employ domain generation algorithms for several strategic reasons. Though I'm going to mention many things, I'm just giving only a few here. The threat actors employ the DGAs for several strategic reasons to control malware and conduct malicious activities. So DGAs allow attackers to quickly switch domains used for the malware attacks and to maintain the malicious scheme infected hosts and the CNC control connect the end access points. And hackers utilize malware to infect a large number of computers or devices within the corporate or IT environments. And then not only here, even for the IoT devices also it is being affected. I come to the next slide. So usually, though the C2 server is usually workstation located within a breach system, right? Intruders can instruct these malware infected computers or bots and gather data from them. So this network of bots is useful for various cyber attacks such as distributed denial of service, spam distribution, and data theft. So hackers utilize malware to infect large number of computers or devices with the corporate IT environments. By using DGs, hackers reduce the traceability of their infrastructures. They are effective against the signature-based security solutions that rely on known patterns and signatures. So DGs provide a meant for advanced persistent threats. We'll say the recent firewalls are making use of this. We'll call it as advanced persistent threat actors to communicate with and control the malware over extended period while minimizing the risk of the detections. So who are all the targets? Though the list are many, I mentioned a few. So victims of the ransomwares, why this DJ is serious? Okay. So though, as I said, no, they're not given the history of the DJ. Actually, the DGAs are being used for more than 2 decades. Still, it's going day by strong in the day by day. But recently, but the past 10 years, in 2008, the first DGA, known DGA threat is being detected. Thereafter, major firewalls, they used it, major operating system also, they made it in the firewall control. So why did they take in this measure is based upon the many targets of the DG. So usually targets of the DG will be victims of the ransomware attackers. Ransomware, they will encrypt our confidential files and they like to get the lump sum money to get it decode or the encode back. So victims of ransomware attacks are often targeted through DGs only. So ransomware variants use the dynamically generated domains. The domains is generated with the DGs for the communication with the same servers to encrypt files and demand the lump sum payments. And the IoT devices, they including the routers, not only the internet manner. So even in case of the IoT, certain nowadays the DJ generated malwares are becomes multifolded. They're highly application specific DJs are also being detected. I'll list it in the coming slide. So as I said, no, this Internet of Things, the malware or the DJ driven malware specifically designed for the IoT devices. I think the name of this particular malware is Mira or Mirai. And there are certain variations of this. I'll come to the subsequent slides. What are the actual cases while talking about the case study. So IoT devices, including routers, cameras, and smart home devices, can be targeted. So not only this, even the VPN also being targeted by the DGA. There, the DGA's mention is they used to generate the instead of DGA, domain names being generated, they will generate the IP addresses. Otherwise, they will generate the domain names, and these domain names being attached with the fake IP addresses. And so thereby affecting the network components. So these attacks may target the supply chain in case of the real-time environment to compromise the software vendors, distributors, manufacturers. Even in the wherever the uh, IP or the intellectual property right or copyright being there also the DGs is being used to for the credential. So universities and research institutions may be targeted for intellectual property theft and sensitive research data to compromise the credential researchers. So there are many targets I listed here. Okay, so let me go to the what are the popular malware that use the DGA. So this is the first, there is a pioneer in using DGA. It's called the Configure, and the Mira is being used for the IO devices. Configure is being used for the first DGA. So usually the configure and the one more thing is the Kraken. The Kraken and the configure are the pioneers in using the DGA. Actually, they are claiming that they started using it from the 2008. But for the past 10 days, major focus is laid on the DGA malware. And then the popular one is the Mirai. It's mainly targeting the IoT devices. So the Loki also, it's the phishing ransomware. It's very serious and the sensitive and the highly venomous one in the non-technical sense for the Loki. And the VPN filter, as I said, DJs are being used for the application specific. This VPN filter malware, DG malware, we can call it strains, right? The VPN filter strain is being targeted for the network routers, storages, and the IoT devices. They're also mainly using for the data exfiltration. Apart from that, they will attach the infected devices. And then apart from that, the popular game or Zeus, and popularly Zeus is the popular malware, and there's a game or Zeus. And then Tinba, it is Tinba is a popular banking malware. most of the security firewalls, they're focusing on this Chimba, Emotet. I mean, many things are there. And these are the list of few DGA families: ABC Bard, Jibakar, CryptoLocker, Fido, Loki, Mirot, and Banjuri, like that. Okay, these are all they're otherwise called as the DGA strains. Okay, otherwise DGA malware strains. So even this simple malware strain may be capable of holding the code to generate the domain generation algorithms. So they before explaining one by one, let me see, take at least one or two, because in our research focus we consider Mirai as the case study. So that's why we studied Mirai in depth for the IoT devices protection. So it uses the 12 character strings and switches to domains only if the hardcore domain fails. And the recent observations noted that IoT devices in the 164 countries there utilize seed-based algorithms. All the seed-based algorithms are the random-based algorithms. Well, any random number requires the seed, but the choose of selecting the seed is different from the other malware by the Mirai. Another popular malware, I mean the DG-driven malware, is a Shagbot. It's a Shagbot is an Android banking malware like Timba, and this Android banking malware that steals the credentials and banking details. So you would have seen that in recent many spams, right, many incidents that they are touching the particular link, they're taking the money. Right? All major is mainly this Shagbot is one of the cases. Based upon the unknown links, right? So it will use to generate the links. So nowadays, no, the link is provided. I mean, we would have heard about an incident just a week back. A vendor receives a complaint from the one particular customer. He tried to pay the money. He just paid just ₹1 in his account, and then he shares this personal of the UPI barcode, UPI QR code, and that amount is being stolen. So the links is being provided by this type of Shagbot malware. So it's a modular malware that the researchers belong to the next generation mobile malware able to perform attacks, automatic generation systems called ATS systems. So automatic transfer systems. So ATS allows attackers to fill in the fields, autocomplete cases, right? A similar kind like this infected device with the minimal human input. So this chart uses a DGA to generate the secondary CNC server apart from the primary one. The primary CNC URL is detected. If it is detected by CNC, it will generate the secondary CNC server. So this DGA was used several times during the further development of the Shagbot. So how the domain names are being generated in the Shagbot is the DJ performs these steps to generate, especially this Shagbot. And what I shown a couple of slides back, the typical domain generation algorithms and the domain names being generated by one. And this is a Shagbot. So take the current week number there, it is 19, it is taking, for example, the week number is say 12. Append the hard-coded string and the base 64 encoder, take the first 19 character and then attaching like this. The algorithm which is shown, the typical one is the core part of this. So what are the practices? So these are the many cases. I can talk about the other strains of the DG malware. So before proceeding, right, let's see how this seminar is mainly talking about, right, what is DG and what are the available and what are its behavior and how to protect, what is the current detection techniques or algorithms from the academic research, right? So let us see before entering into the detection techniques, let us see what are the network practices can be used by the network admins to prevent the DG attack. So either we may configure the firewall or the network may be segmented, or maybe the country's monitoring for the anomalies or for the endpoint protections or the right, in the anomalies in the senses, usually most of the network systems will have the IDS systems, intrusion detection systems. And usually intrusion detection systems are, there are many types. One is a host-based, another one is a network-based. I'm talking about the network-based. Again, the functioning-wise, we'll call it as a signature-based and the anomaly-based. So though the signature-based, they were used widely for many years, but said no, it becomes the attack is being the more intelligent and the adaptive nature. So anomaly-based, the behavior is changing slightly, right? So anomaly-based detection may be more wiser and more protective. So continuous monitoring for the anomalies and thereby using for the intrusion detection systems or the detection points. And then the endpoint protections, the incident response planning. If something has happened, what type of plan you have to make it up. And then collaboration and the information sharing and regular security audits and penetration testings and backups and data recovery. And these are all the network practices to the thing. Right. So what are the measures to be taken by the normal users to avoid it? Okay, it has been happened. This is for the non-technical. And what are the uses to avoid the DGA malware? So we usually employ security software that can prevent malware attacks like advanced endpoint protection solutions to detect and block DGA-based malware, and regularly update this software because even the Microsoft Windows, they having from the 12, like 2012, when though it's not begin stable from 13, right? So 12 onwards, they use try to give the DGA alert, though it's not much effective, right? Though it's try to give the DGA alerts. All popular firewalls are try to have the settings in the firewalls, and it can be configured in such a manner you can avoid the DGA. But despite that, it is being attacked. So refrain from opening an unexpected attachments in normal, as though it's a simple and the normal routine cases. But I want to reiterate in every talk that no, this is a very simple, easy measure, but it's simply advocate. So unless otherwise it is from the known one, you try to avoid the unexpected attachment. So enable the macros, even the nowadays with the words, right, enable the macros even in the Excel file, right? Even in the executable file or even in the cookies fashions, the macros may be attached document without confirming that you can do so. Sometimes certain attachments being come to you, you can doubly check that whether it's having the attached macro. Can help prevent the introduction of the DGA powered malware into the being introduced or being affected like this. So leveraging anti-DGA technologies that use machine learning and the big data to target the irregular activity, anomaly, and implement the DNS security solutions that can monitor the DNS traffic and detect anomalies. So continuously monitoring the DNS traffic and network activity to detect the anomalies. As I said, no, the good IDS systems also to identify potential DGA related threats and consider deploying the advanced firewall solutions and use the Zenarmor or here the Fortinet or the Palo Alto or any machines use the malware. So usually the anti-DGA malware measures by the major like Fortinet, Palo Alto, Microsoft, Juniper networks. Let me pinpoint only the Microsoft and the Fortinet. So usually in Microsoft, DGA alerts are being typically detected by the DNS servers. So you are getting DGA Microsoft alerts. Usually alerts are being detected by the DNS servers, right? Because, but if the DNS servers is being detected, right, affected. So this DGA given by the OS patches of Microsoft, that's what usually every suggestion we're giving is, right, you have to give the always your devices. It may be your mobile phone or maybe smart devices or gadgets or your desktop or even the high-end servers, right? Always give it with the update with the recent security patches. So in the Juniper network, the ATP cloud provides a machine learning based DGA detection model. So by going to the appropriately configured, so why I'm showing this point is how to configure the Juniper networks to use the DGA. So this type of SRX type of firewall series, they are also using the security of metadata and streams the metadata to Juniper ATP cloud for DG analysis. So This is a typical rule based in the Fortinet, how this DGA is. So these measures are being taken only in the last 10 years. At recent, all type of major firewall providers, they are taking care of the DGA. So whenever any firewall is being introduced or any network, security software is being used, please doubly ensure that it is having the DGA detection mechanism and how to make an app. What I want to showing is this is one such a rule. It is being employed in the Fortinet, and this is we'll call it as attack tactics. Right. So we can say adversaries may make use of the dynamic. So by having the certain traces, right, detects algorithmically generated host name in network traffic. So this is a DGA malware often use algorithmically generated host name to communicate. So this is the alert given by this typical firewall. So as I said, no, I don't know whether it's visible in the last row. It's the actual screenshot generated by the Fortinet. So adversaries may let me read out for the bottom screen, right? Adversaries may make use of domain generation algorithms to dynamically identify a destination domain for command and control traffic rather than relying on a list of static addresses of domains. So then only this one you can make it hard to understand. So now let us see, right, how to prevent it, say in the non-technical manner, right? Now let us see them technically how to what are the techniques being used to detect the DGA malware. Okay, either you can use the employ simply the reverse engineering methods and advanced detection techniques to identify DGA activity on networks. So utilizing network behavior analysis to monitor the behavior network traffic systems, application of detection unusual patterns such as frequent and varied domain name requests, and then behavior-based anomaly detection systems like that. Yes, and then raising ability or to differentiate the registered domains from the unregistered ones, and employing advanced firewall solutions for dynamically adapting to defend against DGA-based threats for a more proactive defense strategy. So, as I said, DNS traffic analysis and registering the generated domains and preventing attackers from registering them. So, this will prevent the industry response CNC communication. And DGA activities can be found with the help of threat intelligence platforms powered by AI. So, machine algorithms built into these security solutions and advanced analytical tools. So, let us see what are the challenges in detection. Though we are saying many measures you have to take, and then you are at the heavy high cost of firewall, and then configure such despite all these cases, there will still the challenges in detection of the DG attacks. Why is these factors? So first factor is it's a dynamic domain generation. So constant generation of new domains make it highly difficult for defenders to predict and block the malicious domains. And then evasion of the defenses, evasion of evasion tactic in the sense is, right, it's keep on generating empty number of domain names, right? So as I said, index the non-response replies, and then one such maybe sometime it may be evaded or make an entry into the validated cases. So this type of evasion tactic is designed to counter the actions of security software and vendors, making it highly challenging for defenders to block and take down. So the CNC is it's a prolonged one. So evasion of the defenses and the CNC communication. What's a CNC communication? It's a prolonged CNC communication is, right, the CNC server and the host. It is taking more time, right? That's the time taken by the CNC and the control server. Control server and the our register server and the DNS server is also to be considered for the if there is any prolonged communication between CNC with the servers. And then the detection complexity is multiple levels of DJ detections with each subsequent level correlating to the rise in the severity. And then high resilience, right? Even if some domains are blocked, no, new ones can be generated rapidly. Right? In case of the malwares on the DJs to communicate with the central servers, the prolonged communication infected devices and the CNC servers poses a substantial challenge for cybersecurity, as I said earlier, right? So this will give the high resilient in some domains being blocked. So volumes of domain, thousands of domains can overwhelm traditional detection systems. And encrypted makes monitoring harder for cybersecurity teams. So for this, anti-DJ detection techniques are usually there are many slides. I'm going to talk about the detection mechanisms. Broadly classifying, no, there are the DJ detection mechanisms are based on only the two things. One is whether to make the traffic or not to use the traffic. In the sense, is network traffic or DNS traffic, or not to use the network traffic. If you use the network traffic, we'll call that as context aware. We're not using the network traffic, it's contactless. But contactless, it's using the machine learning methods. The context network traffic, right? As I said, DJ malwares are being highly intelligent and adaptive. So with the mere using only DJ traffic alone, it is harder to detect. So that's what I'm going for the contactless or the DNS analysis. I'll come to this. So this is an intro of the detection mechanisms. So usually all the anti-DJ technology, usually machine learning, mainly for the right DNS analysis, not the, as I said, no, using the DNS traffic and big data to target regular activity. So automatic prediction method that can anticipate, block, and assist. Another one is using the DNS traffic analysis used to detect the DJ-based malware. So monitoring DNS queries, responses, and IP addresses. And the dynamic defense approaches. Nowadays, even the chip-based DJ detection also being affected. You can find it in the literature, or it is being used mainly for the closed network cases and preventing attackers from registering them, using them as connection points or the resource points for the CNC communications. So registering the generated domains can either disrupt the known DGA-based malware. So signature-based detection, so throughout the cyber attacks, but even then it is not effective in the recent cases. So we cannot, because the signature reviews keep on changing, right? Keep on changing. So instead of using the signature-based detections, it's better to go for the anomaly-based detections. So as I said, broadly you can say there's a context aware and the contextless, and the combining this context aware and contextless. As I said, context aware means using the network traffic. So because these type of detection techniques typically slow, usually it's going to be slow. And since we're seeing the umpty number of volume of network traffic to be there in the online. Another one is the contactless or the domain name based detections. So most of the research is being laid on this type of ML, machine learning, and the deep learning method with the CNN advanced one. So broadly, we are also working in contextless domain name based DJ detection mechanisms. May have accuracy with the recent technology improvement in the machine learning techniques. And then the hybrid, which is combining network and traffic domain names. So you can find a good paper on this. I've seen the recent work on the P4, so the last year work, 2023 work. It's a simple processor being designed. I think it is available in the IEEE, and it is being used in the initiative South Korean lab. It's a P4 is a programmable protocol independent packet processor. Usually it is being used in the software defined network in the data plane, because it is how it is combining this traffic and the domain name is, because as I say, no traffic, network traffic analysis is much harder. So packet level analysis, it is very harder. So this type of processors may process this, analyze the network traffic. At the same time, since it's a programmable, it may use the domain name anomalies as well. So DJ detection, this technique is whatever the technique I'm going to say now is based on the second category, like domain name detection techniques. So all the detection techniques going after, I'm going to focus on the DNS. As I said, one is monitoring DNS traffic is slow. So identifying the patterns in DGA generated domain names are the passive DNS monitoring. They'll know that two types of monitoring. One is active monitoring and the passive monitoring. For the active monitoring, you have to use the specific packet or a specific request has to be made. But passive, while doing the other work itself, you can have the additional patches. So real-time DNS monitoring and the ML algorithm static analysis for the direction. So researchers are still more bit level deeper. Researchers leverage machine learning and explainable AI and open source intelligence to predict and block DJ domains effectively. So learning patterns and features. Though in the ML they are using supervisory and unsupervisory, still we are working on the supervisory. So unsupervisory learning, it is an anomaly detection being used for the unusual patterns. Just sometimes they may use the unsupervised learning just to detect and pass it on to the next detection model. But main model may be in the supervised learning cases. So botnet detection techniques, in case of the behavior analysis, either you can use the network traffic, the CNC behavior, or the host behavior, or the botnet propagation and exploitation, and the anomaly detections. So in case of network traffic analysis, I repeatedly mentioned high volume of DNS requests, and then as I said, the CNC control, this prolonged CNC or malware relies on DGAs to communicate with servers, or having the prolonged communication between infected devices and the CNC servers poses substantial challenge. So we'll using that behavior. And host-based behavior, so it is the increased CPU usage unexpected. It's a you're right. Usually in the DDoS detection, how you are finding is too many dropping of the packets. How you are finding too many dropping is using the behavior. So how the botnet is propagate and generates and moving to the other nodes or otherwise unusual scannings, the patterns or code scannings. So this type of detection mechanism, what are the bracket, to give the points. So anomaly detections, deviations from the normal traffic or DNS behaviors. So there are proactive measures and collaborations, legislation and awareness. So using predictive models to anticipate and the generated domains and blocking all possible domains associated with the DG pattern. And collaboration is you can cybersecurity communities are reaching the DG detections. And then encouraging ISP to monitor, because this is in case of the IP monitoring cases. So from this, let us take this, based upon this technique, we are working on this DJ detection algorithms. I'll just pinpoint certain points and what we are doing in the detections. So, right, apart from this RCC, right, we are having some professor. We are coming to computer science as a professor. Apart from that, we are taking care of the computer center. It's a web service, right? Major thing is we are taking care of the unadministered domain. It's ours is a highly it's a hard cake for the attackers. So we are using 1480 firewall. So there we are having a mini stream. So every second we are getting this, try to get the attacks from various part of the globe, and then we are given for our 1480 team to get it analyzed. So we are making use of these data for other research purposes as well as for the analysis purposes. So usually from there you can take the learning patterns and distinguishing legitimate domain names from the DGA generated ones. So let's see, from continuous learning and the adaptations are the crucial. So our detection algorithm also, how it is adapting, let us see now. So integration of techniques, adaptive and proactive strategies, real-time application and interesting relevance, right? So since the existing DJ detection methods rely on static signatures, there's a need for the dynamic and adaptive detection methods. So our in the sense is, my research work, right? So I have a team. This paper, the first paper is unveiling domain generation algorithm in DNS log traffic, right? The first, both papers are, it's my research scholar. So first paper is being accepted and it is there in, it is published in IEEE, this one. The second one is, review is completed, it is yet to be published, waiting for the DY. So let me give some insights on our first work, what we are doing in this dynamic detection. So our detection algorithm also is dynamic and adaptive in nature, and we are using DNS log traffic. Right, though we are using the DNS log traffic, right, we are combining the DNS analysis as well. The first one is using the DNS traffic, and second one we use the GNN, we call this graph neural network and the federated learning. So let me give some insights on our first work. So you can, in your free time, you can check it out. This page you can freely download our paper. So this is the framework we designed for the dynamic framework for the anomaly detection, which is making use of the machine learning technique. So we used more than one machine learning techniques, and we are combined. So usually botnet traffic data streams, though we are having our own data, but for the publication, for the standardization sake, we have used the standard data sets. And then we have the feature extraction and the pre-processing, and this machine learning intelligence is here on its our algorithm. And then we use the decision trees, D2, random forest cases, and then we are combined with the usually ensemble algorithms are usually combining with the two major techniques, right? Boosting and the bagging. So bagging is based on the voting, and then boosting is nothing but improving with the appropriate algorithms advantageous or otherwise prominent factors. So we use the both boosting and the bagging techniques to while ensemble. So you can get the detailed algorithms in the published paper. So usually we, apart from while for the feature extraction, we use the DG graph embedding, and then from there we use for the traffic monitoring. So the traffic monitoring only is being used for the machine learning, and then based upon this supervised learning, we are using the adaptive learning strategy. From there we are getting the use these certain optimization techniques to detect whether it is being busy or not. Though theoretically, I am saying always the academic research in the sense, right? Unless otherwise it fit into a real platform, then we know how much it means succeed. So to get a paper work, we are getting, though we are using standard data, both from the net as well as from our own data, right? And to put it in the real fiber, how it works. So those who are interested in doing the research on the digit detections or security, or we can make use of this. So how to unveil the DG is like unveiling the DG and DNS traffic and dynamic detect anomalies through the ML analysis. Usually the interconnected models are so it's many, right? So this is a framework which combines these models. And another one is the prominent feature of our work in detecting the DJ is using the embedding technique. So because as I said, the main challenge is how to distinguish our genuine domain into the the DJ generated domain. Though all possible domains are being considered, right? This graph embedding is being highly used to identify the malign domain extension compared with the genuine ones. So usually this graph embedding aims to capture the structural information and the relational dependencies within the graphs while reducing the computational complexity. So usually actually the graph embedding is being used in mainly on the social network analysis recommendation systems, but we used here to distinguish the domains, and it enables the machine learning models to efficiently process and analyze the graph data, facilitate tasks like node classification, link prediction, like that. And then it enhances the understanding and utilization of the complex network structures, contributing to the advancements in data-driven decision making and predictive analytics. So though this method is being used, as I said, the right? As I said, no, the DGA malwares are being used for the major purposes for the DNS traffic, as well as for the IoT devices, as well as for the VPNs, right? So this is mainly for the internet traffic. So like to extend for the VPN traffic as well. So I've not gone through the second work. So let me. The second work is also, since the second work is in the review, right? I'm just refraining from putting it here since it's affected in this finger. So this also based upon the detection of the network traffic is using combining how the GNN and the federated lining is being used. So that's it from here, right? So any queries or being
Any questions?
I, so
Ma'am, take photo session.
any queries? So actually, I thought of presenting our both papers, right? So the the techniques what I given here is mainly for the internet traffic, but you have to take the special measure for the VPN traffic as well and the IoT devices, and then separate the DG detection mechanisms is nowadays is being designed for the IoT devices. So another team is working on the IoT security. Here also, there also we are mainly focusing on the DG detections and how to detect the DG streams. So any queries
There
so
is
far?
one question in chat box, sir. How to collect cyber security data sets?
Yeah, I mean the cybersecurity data sets are being provided by the major firewall providers like Fortinet, Pactel, Juniper networks like that. And apart from that, the common forum is available for the data security. They are having the data sets on many cases, but only thing is the what I'm shown here is DGA based data sets, and these data sets are available mainly available in the net. But cyber data, I mean, cyber security data sets are in the, we cannot say commonly it's a cyber security data sets. As I said, nowadays the cyber security poses a major threat. The data sets are available in the different contexts. So you can get it from the major firewall and the STP or the common security forum. If you want, let me share through the chat box itself common certain portals in which you are getting the data sets. But here what we are using is, apart from using the standard data sets, we are using our own data set. Since we are using Fortinet, the Fortinet log analysis we are using. So either they can make use of the log report generated by the firewall, either like Fortinet or Palo Alto like that. They can get it from the academic or standard data set to be tested on the detection mechanisms. What is the role of blockchain in the cyber security? They're asking. Actually, blockchain is altogether is totally different technology. Actually, here I focused mainly on the detection of detection mechanisms, techniques of the some malware. And once there are many malware, and one typical malware is DGA. I mean, the malware driven by domain generation algorithm. If it's very easy, simple. You are getting some mail from someone else, you as if you it is coming from. someone is genuinely your friend, but it's not the mail coming from a friend, it's from someone else. So as if the mail is coming from someone you are receiving mail, right? Similarly, if you are say having certain domain name, you may remember, you may think that that is a genuine domain name, but it may not be. So this is a purpose. But blockchain technologies, the way in which you protect the data, you can use the blockchain. For example, in case of the IoT data security, if you want to have the all the devices under your IoT system, if you want to make blockchain technology, you can design it. Right? Am I answered the question? I mean, what is the role of blockchain in the cyber security? Is broader question. I'm answering in the context of DJ detection and the blockchain. So DJ detection and blockchain may not be comparable. So blockchain is being used to protect the right or the devices or the systems in any network. It is already being traced how to detect what are the mechanisms available, and that is our this focus of this work. And what are the challenges and solution in the endpoint endpoint detection, right? What are the challenges and solutions in the endpoint detections and the responses? Right. Here is because again my focus is on the DJ detection. So endpoint, I think one of the slide I mentioned about this endpoint detection. This I mean this work is mainly on the how the domain names are being generated and traced out. Okay. So the endpoint response may be useful as a one of the factor in detecting the DGA. So that only can answer to this question. And what about the concept of micro segmentation in network security? Actually, what is mean by segmentation in network security is, assume that I think one part I mentioned when we're talking about the different malware variants available in the market. I mean, the one is I think VPN, I think mentioned, right? So that that one is mainly to affect the network devices. Suppose if you find that if you detected that network is being affected, and then that network has to be segmented, and then that part of security, right? You can use they mentioned about the concept of micro segmentation, right? Micro segmentation keep on subnetting the networks into the core level and then provide the security to the particular point. And what are the challenge solution in point detection? That's one answer. Any other questions? Difference between explainable AI and the deep learning. Okay, so let me on this. What is the difference? Someone has asked, what is the difference between explainable AI and the deep learning? So first, let me put a word on the what is AI and what is explainable. I mean, I think that you can say the machine learning, right? Machine learning, I'll give you a very simple explanation to this. Assume that machine learning simply gives the prediction. Okay, explainable AI, it will just give the interpretation. So how it works, what are the cases? So here sometimes we may use why they used here I mentioned explainable AI is how we are detecting is based on the certain right, behavior analysis, as I mentioned, certain anomalies in the behavior of the DNS cases. So why it happens, somehow it has been machine learning is find out. But if you do the explainable AI, you can have the more in-depth interpretations. This interpretation may be highly useful in detection the DGA malware. And then deep learning, that's it, actually it has to come in different ways. The deep learning will be used to detect whether it is malware or not. And the interpretation will be given by the explainable AI. And, yes. For malware data set, how can we generate our own data sets? I think someone is asked about, sir, for malware data sets, how can we generate our own data sets, or should we work on available data sets only on research purpose? Because our problem statements are specific to own research, so how should we go? But especially for this type of detection techniques, right? It is better. Sorry. I think some noise is coming out strongly. Please switch it off. Hello, please. So someone asked for the malware data set. How can we generate our own data set, right? But it is better to avoid your own data set. Why I mentioned our own data set is, since I'm heading the data center now, so we are using Fortinet firewall. I'm taking care of the log set of that Fortinet firewall, because ours is a very popular domain and we are getting many malware attacks in right behind the firewall. So we are taking that log analysis for our analysis purpose. Even that is we cannot maybe correct because it is not being affected, right? So it is better to avoid the data set, because the this is one side and the practical guys. At the same time, we want to publish some paper, right? Not only for this security, I mean this field. In any field, if you want to publish a certain paper in a standard reported journal, right? Suppose if you use your own data set, there may be suspicion that you use certain cookie data, synthetic data. So to check whether your algorithm works or not, no, you can have certain modifier like a simulator. But to publish a paper, you must require either standard data, or you explicitly mention, for example, in we will explicitly mention, okay, we are taking the data set from these firewalls used in this domain, like that. Okay. Hope so I answered for this question. Though your problem statements are specific, right? But it's better to, if you want to get published in a good journal, it's better to use this data set or data set, especially for this type of detection technique. I use the data set of the traffic. Our own means doesn't mean that I cook the data, but it is the real time data. Even other work, as I said, now we are providing network also. For the wireless Wi-Fi security, we collected the data from various access points. We have more than 1,500 access points. Suppose any intruders are there in between, those houses are secured Wi-Fi. Want to check now, you have to collect the data from various access points. So we'll have this data. Apart from that, we'll get the standardized data. I think I answered.
Yes, sir. Sir, actually, we have the photo session now. So
Okay.
I ask everyone
Okay.
to switch on your camera. Okay, thank you.
Okay.
Ma'am, give water, thanks.
One more query is there, sir, in the chat box. Cyber security data set list
Oh,
faculty is asking.
okay. Listed, I cannot answer here, right? So you can get it from that's what you know, major, most of the firewall providers, they are giving the standard data set. Okay. Otherwise, that's what, let me share while giving this PPT material, let
Sure,
me
sir.
share the
Yes, sir.
list
Yes,
of
sir.
data sets.
Sure, sir. Sure. Nalleeswara Rao, sir, we'll get the list from sir through his
Okay.
PPT and we'll hand over to you.
Okay. Thank you.
Yes, thank you so much,
Yeah.
sir. It's my immense pleasure to thank at this moment for you. In spite of your busy schedule, you accepted our invitation. And even though this is a holiday Saturday, you spent your valuable time, 1.5 hours time for us. Sir. Thank you so much for your informative session, sir. We got a very good feedback about your session that your entire 1.5 hour session is very much informative like that, sir. Thank you so much, sir.
Thank you, ma'am. Thank you for the opportunity. Thank you for your patience hearing. Thank you for the good response. Thank you.
Thank you. Thank you so much, sir. Yes, sir. Yes, feedback link for this session is shared now. Dear participants, please fill the feedback form.